Everyone, welcome to week 9, programming with C++, and I am excited to dive into one of the most important of C++. These are our learning objectives for today. You will learn the concept of classes. You will learn about access control, constructors and destructors, and the member function and attributes, static members, and memory allocation and member initialization. Let's begin with classes. Talk about classes. What exactly is a class? A class is a user-defined data type that when used in our program, it works as an object constructor, or a blueprint for creating objects. That's a class. So a class is like a blueprint or template that you create to make objects. Think of it like a cookie cutter. The cookie cutter is a class, and each cookie you make is an object. More technically, a class is a user-defined data type that works as an object constructor. It's your way of creating custom data types that can hold both data and function together. Inside a class, we have two main components. And these components are, we have the attributes, and attributes are like variables that store the data. And number two, we have the method. These are like functions that can manipulate that data. So we often call these class members because they belong to the class. Now let's see how to actually create a class. The structure is quite simple, and this is the structure. Class name, your access specifier, the attribute, then your method here. Notice three important things here. We start with the keyword class. We give it a name which is following the same rules as variable names. Then we end with a semicolon as terminating after the closing braces. So let's look at the code here. This is the code. Here I have created a class called myRecord. The public keyword is called an access specifier, which means that the attribute my age. The attribute my age and my name can be accessed from outside the class. And inside the class, we have two attributes. That's my age, which is an integer to store someone's age. And then we have my name, which is a string to store someone's name. This is like creating a template for a record that can hold a person's age and name. Let's move to, now we have the class keyword. It's used to create a class called myRecord. The public keyword is an access specifier. We've already discussed this. We discussed this also. Let's move to the class method. A class method. These are the components of a class. We have the attributes and methods known as the members. The attribute refers to the declaration in the class that stores data. Method refers to the definition in the class that are used to manipulate the attribute or properties. Then class methods. Let's discuss our class methods. The methods are functions that belongs to the class. And we have two ways to define function that belongs to a class. We have the inside class definition and the outside class definition. Methods inside class definition. Let's have a look at the structure here. Inside, this is the code. Class myRecord. We have the public keyword. We have the void function get my age or get age here. We look at the outside code also. You should notice one thing: the semicolon, the colon, void myRecord, the two double colon, get age. We've already spoken about this thing in our previous lesson, lecture 8. Let's continue with class method parameters. We have the parameters. Just like regular functions, class methods can accept parameters also. So the set info. So parameters act as placeholders for the data to be accepted by a function. In classes, methods can be provided parameters for arguments to be accepted when calling the methods. This is an example structure. Parameters in class methods. This is the code. Define a method in my record class. The set info. This is argument in class code. This is an argument in the class code. Have a look at it. My record wonder. I have the cout, have wonder.getAge. Coffee here. Let's move to class constructors. Class constructors. A constructor is a special method that is automatically called when an object of a class is created. So to create a constructor, you use the same name as the class followed by the parentheses. Constructor is a special method that runs automatically when you create an object from the class. It's like an initialization function. So here are the rules for constructors. First, the constructor has the same name as the class. Second, it has no return type, not even void. The third is usually declared as public. The fourth, it runs automatically when an object is created. You can also create constructors with parameters. Let's have a look at the structure code. So we define the constructor in the myRecord class. In this code, we are defining myRecord as a constructor. And it's the class myRecord, public myRecord. Here. Continuing with the destructors. A destructor is a special method that is automatically called when an object of a class is destroyed or ends. Bracket scope of an object ends. It deallocates all memory used for the creation. To create a destructor, we use the tilde followed by the same name as the class, then by the parentheses. So just as constructors create objects, destructors clean up when objects are destroyed. So a destructor is called automatically when an object goes out of a scope or is explicitly deleted. And how to access specifiers. Now, how do we access specifier? Let's have a look at the destructor code. This is the code. We are defining a destructor in the myRecord class. So class myRecord public myRecord. Here the destructor cout here. Now class access specifiers. What are they? Access specifiers, also known as access modifiers. They control how the members or attributes and methods of a class can be accessed. They help protect data and organize code so that only the right part can be seen or changed. So access specifiers control who can access the members of your class. And there are three types. You have the public, you have the private, and you have the protected. Public, private, and protected. So the public, members declared as public can be accessed from anywhere, inside the class, outside the class, and from other classes also. So you need to specify that a member of a class should be public in order to access it outside the class. Now, when we talk about the private, the private is declared as members are declared as private. Sorry, members declared as private cannot be accessed from outside the class. So by default, all members of the class are private if you don't specify an access specifier. So members declared as private can only be accessed from within the same class. And this is the default access level. For our last point, we have the protected. Let's have a look at the private code. This is the code of the private. Let's have a look at the protected. Members declared as protected cannot be accessed from outside the class, but they can be accessed in child classes. Members declared can be accessed within the class and by child classes. We'll learn about inheritance later. Have a look at it. Protected. So declare a private attribute into my record class, public into my age, private, then string name, then class. As you still continue with the class, we have the this pointer. The this pointer is a pointer that points to the current instance of a class. It is used within the member functions of a class to refer to the object of that class. It allows access to the calling objects, data, and methods. So this pointer is a special pointer that points to the current object. It's useful when you need to refer to the object itself. It allows access to the calling object, data, and methods. Let's have a look at the code, structure, and syntax. Creating and using objects. Creating and using objects. What are objects? An object is an instance of a class, and they are created from a class. To create an object of a class, we specify the class name followed by the object name. And these are the syntax. Let's have a look at the syntax. Here is the syntax. You have a constructor with parameters. Access the class members. Use the dot operator to access public members of an object. Modifying class members. Static members. To multiple objects. Multiple objects can be created from a class. Class provides the blueprint to creating the multiple objects. And this is also the syntax here. My record Jemima, semicolon, which is the termination. My record Julia, which is also terminated. So accessing class members. How to access class members? First, use the dot operator to access public members of an object. Class members can be accessed when objects of the classes are created using the dot operator and assigned name. So this is the syntax example. Object dot member is my record Jemima, then Jemima dot get age. We have Jemima dot get name here. And also we have the modifying class members. Modifying class members attribute. Class members that are public attributes can be modified using the assignment operator equal to. This is the structure or syntax. Is the syntax. My record Jemima dot age equal to 34. So you can modify public attributes directly. I have the static members also. Members of a class can be declared as static. And static members are not associated with objects of a class, but the class itself. It can be accessed directly through the class without creating objects. Both the attributes and methods can be static members. Well, static members belong to a class itself, not to any specific object. So you can access them without creating an object. Let's have a look at the structure. This is the static members. You declare static attributes in my record class. Public static string, my day of birth. Let's continue with object-oriented programming concept, OOP. Object-oriented programming concept. You have the OOP. So what is it? It's about creating objects which can hold data and functions that can work on that data. So classes are used to implement object-oriented concepts such as encapsulation, inheritance, and polymorphism. They help us implement Let's dive deep into this one by one. Let's begin with encapsulation. Sorry, let's start with inheritance. When we talk about inheritance, what is inheritance? Inheritance allows one class to reuse attributes and methods from another class. It helps you write cleaner, more efficient code by avoiding duplication. Inheritance allows one class to inherit properties and methods from another class. So you have the types, you have the derived class, which is a child, a class that inherits from another class as a parent, and we have we have the base class, which is the parent, the class being inherited from by the derived class, which is the child. Now we have the encapsulation. Encapsulation ensures that sensitive data is hidden from the users. So the use of setter, which is a set, and getter, which is a get, allows reading and modification of private members. The use of friend function allows direct access. So encapsulation means building or bundling data and methods together and controlling access to them. We use private members and public methods to achieve this. We have polymorphism as our next one or last one, which means many forms. Many forms. And it occurs when we have many classes that are related to each other by inheritance. It uses methods inherited from another class to perform different tasks. So the same method can behave differently in different classes. There's a practical example of the polymorphism. This brings us to the end of the week 9 lessons and this assignment. You incorporate the use of classes in your tasks on student